thanks for letting me presenting here. We are OceanOPS. I'm representing OceanOPS, which has actually changed its name recently to OceanOPS, following a whole strategy planning, and to have a more clearer and accessible name. So today I'm going to present who we are, what we do, and how we do that, and especially including all the Esri technologies that are involved in our day-to-day activities. So who we are? So we are a joint center from the WMO and the IOC of the UNESCO, in charge of assisting, coordinating, and monitoring the in situ ocean observing systems, part of the GOOS. And to do so, we technically we collect metadata from all those different networks, and we try to harmonize them, integrate them, and we quality control them so that we can produce in the end integrated products and fulfill our missions, which are listed on the right of this slide, which are ensure that timely data and metadata exchange are met. Also to assist in the implementation and the deployment planning of these networks through the identification of opportunities to avoid duplication of efforts and to take benefits of international cooperations. We also try to identify existing sources of ocean data which are not yet shared within WMO and IOC, and we help them to share and promote their data and metadata. And to do everything, we base our day-to-day work and all of these missions on the development of monitoring tools. So how now Esri takes place in all those activities? So to start with, we really have Esri in technologies in all layers of what we do, starting into the scripts. So we produce a lot of pair-based approaches as well as global approaches, like being able to query what is operating in the Indian Ocean, for example, or how many observations are delivered on target in the Med Sea, for example. We also compute gridded products like density of coverage grids to help in the implementation of those different networks. And one of the main and most important product is the near real-time tracking. It goes through the track line computations of every drifting instrument. We try to match if they are, to determine if they are, if instruments are going under ice. And according to an IOC resolution, we also produce maritime zones warnings. For example, when an cargo float is about to drift into territorial sea or exclusive economic zone. Now we also have a lot of communication products which are based on Esri technologies, and the first ones are our monthly authoritative maps. This is one of the latest we produce using the spillers projection. These maps are used by all the communities, scientists, to government bodies and governing bodies, and this is our main product, really. Then we compute KPIs, as I said, either using a global approach or a per basin approach. We release every year the Ocean Observing System report card, which is mainly based on statistics and maps analysis we produce to report on the efficiency and implementation of those networks. We have released a couple of story maps until now, one for Argo when they reached the 2 million profiles collected, which was a big milestone for them, and one to, I'd say, kick off the ocean gliders monitoring inside at OceanOPS. Then with the help of Keith, we have pushed the Argo real-time tracking location services to the Living Atlas, and we plan to push the other ones for the other networks. And one of our most advanced product is our web application, our website, which is actually a map centered using the ArcGIS API, where you can find a lot of different tools to filter, for example, your sample of platform or stations you are considering inside the website. You can change the projections, and you can explore everything. And this sample, for example, I'm showing here on this video, is everything that is able to measure subsurface temperature. Then inside, once you have filtered your sample, we have developed this specific tool, which is using the 3D approach to it. It's to be able to filter in depth what is measuring. So this is still only subsurface temperature. So here, for example, I'm querying the system what is measuring subsurface temperature between minus 2,400 meters and 600 meters, 6,000 meters. And we can see that mainly we have Argo deep floats and some moorings only measuring at that depth, which is really handy to just to show what is measuring that parameter at that depth. And finally, one other advanced thing we developed is how to show and discover the data. And especially we started with Argo because we can easily access Argo floats data through some services, including one in Ifremer using AirDAP. So we are able to fetch every Argo profiles and display those in 3D like this. You can like query each and individual bins of this profile to show the data itself. You can also change the symbology as you want to reflect the extent of the data you're showing. And this is highly facilitated by the different functionalities that the GS JavaScript APIs provide. And it's also a good way for the deep Argo community also to see, to really show in 3D how the deep Argo flows can follow a trench or something like this. We use this as well to show marine lines implementations. Every sensor on the marine lines, for example, it's really handy. And knowing also what's being measured on that marine line. So that's it for my presentation today. I'd like to conclude by saying that we have been using Esri technologies for 20 years now, the beginning of JCOMOPS and OceanOPS, so it has been really useful. We have always followed all the innovations proposed by Esri, and we are always like looking at all the release notes of the JavaScript API, myself actually. And we have much more to come in what we want to do with Esri technologies, including the time dimension we want to exploit. Thank you.